Good day everyone, I am Harini Chandran.
I am Durga Rajkumar.
I am Cecilia.
I'm Devi Gunalak.
I'm Nishanti.
And we are from SFE 1023 Group A.
And today we are making a homemade battery using
Coke and salt water.
The objective of our experiment is to make a homemade battery and to determine the terminal voltage and internal resistance.
The materials that we will be using is voltmeter, 2 bottles of Coke, cups, crocodile clips, and an aluminium can.
Emitter, salt, copper stripe, sandpaper, LED light, and resistors.
Using a pair of scissors, cut off a rectangular stripe from an empty Coke can. The stripe should be in a rectangular shape and it should look like this. Next, use a sandpaper to remove the coating from the tin. Also, cut out 12 copper stripes which are also rectangular in shape. After cutting out the aluminium stripe and the copper stripe, place each one of them into one beaker.
All the 6 cups will fill with 3/4 of Coke. Another 6 cups were filled with 3/4 of salt water.
Pour the salt solution into a cup.
We used 6 cups of Coke and 6 cups of salt water. We connected each cups using copper stripes and aluminium stripes in a series arrangement.
Finally, you would get a circuit like so.
What is the meaning of the internal resistance?
internal resistance is the resistance offered by the source of power in the electrical circuit, Devi.
Nisha, what is terminal voltage?
Terminal voltage is the voltage output of a device which is measured across its terminal.
Results of our experiment. The value of voltage without resistor from our homemade battery was 5 volts, and the voltage values and current values for different type of resistors, which are 10, 22, 33, 47 and 51 ohm, were also recorded as shown in the table. The graph voltage versus current were plotted. Here, let's see how to calculate internal resistance. To calculate the internal resistance, we have to use the formula VAB equals to EMF minus IR. The EMF value can be found through the graph. As shown, the general equation of graph is y equals to mx plus c. So that we have to change the equation of internal resistance to VAB equals to negative IR plus EMF. So here we can see that EMF value is y-intercept in graph. The y-intercept of the graph is 3.5. So the EMF value is also 3.5. Now let's calculate the internal resistance of 10 ohm resistor. This 10 ohm resistor consists of voltage 4 volt and current 0.4 ampere, and the EMF value is constant for all resistor because it is taken from the graph, which is 3.5 volt, and we need to find the internal resistance. Now we can include all the values that we have in the formula, and now we can calculate the internal resistance. So here we have the internal resistance for 10 ohm resistor, which is negative 1.25 ohm. The same method of calculation is also applied to find the internal resistance of other resistors too, which is 22 ohm. The internal resistance is negative 2 ohm. For resistor 33 ohm, the internal resistance is negative 2.5 ohm. For resistor 47 ohm, the internal resistance is negative 2.6 ohm. For resistor 51 ohm, the internal resistance is negative 2.5 ohm.
To ensure that the circuit is working, connect it to a LED light. Connect the LED to the crocodile clip to ensure there is a current flow in the circuit. Therefore, as you can see, our battery is able to generate enough light to light up the LED.
In the first trial, we used a cup of Coke. However, it was not enough to obtain the value of the voltage. Then we used 3 cups of Coke, which was also not enough to obtain the value of the voltage.
In the third trial, we used 6 cups of Coke and 6 cups of salt water. The salt increases the conductivity of the battery.
To improve the output of the battery, we can also use rheostat instead of resistors.
Another suggestion is that over time the conductivity of Coke decreases. Therefore, we have to replace the cups of Coke again.
As a conclusion, we have successfully made our homemade battery which generates enough voltage to obtain the current and calculate the internal resistance. We have achieved our objective.